Hello, boys and girls. Or maybe I should say hello, my fourth grade friends, and welcome back to Thursday's version of Day 12 Number Corner. It is January the 21st, and we're almost to Friday. So that, in and of itself, should make you feel very excited and ready to start our Number Corner lesson for today. We have a few things to do today, but hopefully we can get through them fairly quickly. Not just about with a quickness, but also with you thinking deeply about the content, the concepts that we're going over, and participating with me. So let's get started. Today is January the 21st, and here is our shape for today. You can see it here. What is this shape called? Right, it has four sides, so it would be you got it, it is a quadrilateral. And what is the area of this quadrilateral? We have 1, 2, and then we have, looks like about 3/4, and then another fourth. So we have 3 as our area for this shape. Nice. It looks like our shapes have continued to follow the pattern. Just to review the pattern, let's look at these 2 calendar markers here. Here's the marker for the 13th and the 14th. What is their relationship? They're similar shapes. They're both squares, right? It's just that one is bigger than the other, and it is bigger by how much? We've talked about the area specifically and how we can find one area by looking at the first shape or the smaller shape to figure out the area of the larger shape. Do you remember? It's 4 times bigger. The area is 4 times bigger because this shape has an area of 2. So half plus a half is 1. Another half plus a half is another 1. 1 plus 1 is 2. So then we would think that this area would be 8. Let's check. 1, 2, 3, 4. And we have half and half is 5, 6, 7, 8. So the area is 4 times larger. Let's look at the sides though, the side lengths. This has a side length of, I'm going to call it 1. If we were to turn that shape, it would fill up one of these, 1 square unit. So 1 by 1. Each of these squares are a 1 by 1, so we say this is 1. So this would be a length of 2. So this increases, it doubles. And the same for this side because we know a square, all the sides are equal. So I could say, for my multiplicative comparison, for my area, I had 2, and it got 4 times larger, so that would be 2 times 4. Okay, that's my multiplicative comparison statement, which gave me an area of 8 square units. If I'm looking at the side lengths, I could say 1 times 2 because it doubled. And remember the relationship between the 2 shapes, that they these shapes are similar, right? So they're the same shape, just one is bigger than the other. The second is bigger than the first. Okay, we good? All right, let's look at our collector. So again, it's day 12 of the Number Corner activities, but we've been in school for 13 days. We did have that e-learning day where you didn't see my face. So for day 13 of school, we have 13 times 3. How many quarters do we now have? 39 quarters. We can even look at 36 and add 3 more to it, which means I have 39 fourths. Each one of those quarters represents 1/4, and I have 39 of them. Well, let's write that as a mixed number. 39 divided by 4. We know 4 times 9 is 36, or we should know, right? And then we have 3 left over. So we could also look at, yesterday we had $9, or 9 whole dollars, and we added another 3/4, which is 3/4. So that would also kind of give us a hint as to what our mixed number is for today. So that means we can write our dollars amount out, because we figured out when we looked at the patterns here that anything that had 3/4 was worth how much cents? 75 cents. So now we have $9.75. All right. Now we're going to talk again about number lines. Y'all remember when we did a number line that measured about exactly 1 foot long, and there was a ruler underneath the number line, and we put some fractions on here. We put halves, fourths, and eighths. Today we're going to do the same thing, but we're going to use thirds, sixths, and 12ths. Okay, we are going to start with our thirds. And even though we don't have a ruler underneath here, we can kind of estimate where a third would go. So if I'm comparing it to my first number line, I know a third is less than a half, but it's closer to 1/2 than it is to 0, I think. So we need to have 3 spaces on the number line for us to have separated our number line into thirds. So I'm going to take my third and I'm going to move it about, let's say, right here, because we also know that a third is bigger than 1/4. The more pieces you cut it up into, the smaller your pieces are going to be. So if I want to share with somebody, if I had to choose, I would definitely choose to share with 3 people rather than 4 people, because that means I'm going to get more. Okay, so then 2/3 is bigger than a half. So I'm going to put 2/3 about right here. And it may not be perfect, but it's about the same distance apart. And I'm just taking my fingers and trying to measure it on my screen because I'm eyeballing it right now. All right, so 1/3, 2/3, where would 3/3 go? Right, 3/3 is equivalent to 1 whole. A number over itself is the same thing as 1 whole. So let me move 3/3 to 1 whole. And I'm probably going to move it over just a little bit more. All right, so we're good. Now, can we use that information to put 6 on our number line? Yeah, so let's do it. How many 6 are equivalent to 1/3? Think back to those egg carton fractions that we did earlier this year with our Bridges lessons. 1/3 would be 2/6. So that means 1/6 is going to be half of 1/3. And I know 2/6 is exactly the same as, if I'm talking about the whole, the wholes are the same, which in this case it is, it's a number line, then they are equivalent fractions. Okay? 3/6, what do we know about 3/6? 3/6 is the same as 1/2. If the numerator is half of the denominator, that's another hint that it is 1/2. And 4/6 is then equivalent to, right, 2/3. So I'll align it with 2/3. Then we have 5/6. 1, 2, 3, 4. Right, halfway between our 2/3 and 3/3. And then we have 6/6, which is also equivalent to 1 whole. Now, what then is the relationship with 12ths? If you notice, we did not put 12ths on our number line with halves, fourths, and eighths. Why do you think that is? Yeah, so right now we're looking at multiples of 3 in essence. So when you count by 3s, you get 3, 6, 9, 12. So when you count by halves, 2, 4, 6, 8, 10. So maybe we could put 12ths on our number line, our original number line. But first we'll start to think about 12s on the number line that we're doing today. 12s. So we know a third. If you were to split a third in half, you would get a 6. So how do you get a 12th? Yeah. So a 12th is half of 1/6. So I can put my 12 here, 1/12. And then I have 2/12. And then I have 3/12. And then I have 4/12. So as you're watching me do this, I would love for you to draw a number line in your notebook and see if you can locate the fractions on a number line independently. So you're welcome to turn off the sound to this video and see if you can do it, or turn away from it, or pause it to see if you can do it on your own, and then check your work by coming back to finish this video with me. Look at that, 6/12. Remember, half the numerator is half the denominator, then that's a sign that it's equivalent to 1/2. Yeah. A lot of fractions that are going to be equivalent to half. Are you guys seeing what I'm seeing when I end up putting my 12s? Like, I can click on this, and if you paid attention when I moved it, you may have seen that red line is kind of measuring where it is on the page. My 12s seem to be lining up with my 4s. So 3/12, and I know this is not perfect, but 3/12 is equivalent to 1/4, which is equivalent to 2/8. And I really notice it when I put my 9/12 here, because they are all the same distance. So if I'm going from 0 to 9/12, that's the same distance as if I were to go from 0 to 3/4. And it's the same with 2/4. And we know that because any number that's half of the numerator is equivalent to 1/2. All right, and then 12/12 obviously is equivalent to 1/2. So I really don't even have to really move it. But I just did, so let me make sure I move it the right way. Okay, so now that we have our number line here, let's think through some equivalencies or some comparison questions. And here might be a better representation of the equivalence with 12s and 4s on this number line. Okay, so how many fractions are equivalent to 2/3? Or can you find a fraction that's equivalent to 2/3 and tell me what it is? Four, 6. Right, look, they go the same distance. And 8/12. How about 4/12? What's equivalent to 4/12? 1/3 and 2/6. How about 6/6? Now there are a lot of different answers for this one. 1/2. We got 2/2, 4/4, 8/8, 3/3, and 12/12. Awesome. Can you think of a fraction, and maybe you know, but I'm going to ask this anyway, because I kind of already hinted towards it, that's equivalent to 3/12. That's not on this number line right here. Think about 3 maybe candy bars, and you're going to divide them amongst 12 people. What fraction of a candy bar are each of them going to get? Yeah, do you remember I said that they're equivalent to 1/4 and 2/8? And we know that's true because 12 is a multiple of 4. 8 is a multiple of 4. So I could simplify 3/12 to be 1/4, or I could multiply 1/4 by 1/2, where my fraction is 3/3. If I multiply 3 on top, I got to multiply 3 on the bottom, and I'm going to get 3/12. So that is equivalent. Which one's bigger? Is 5/12 bigger or 1/3 bigger? 5/12 is bigger because it goes farther on the number line, so it has a longer distance. How about 1/6 or 3/12? 3/12. You're right. 3/12 goes farther. Which one's smaller? 5/6 or 12/12? That one's easy. 5/6, right? 12/12 is one whole, and 5/6 is 1/6 away from one whole. So we know, even without looking at the number line, or should know, or think about, without looking at the number line, that 5/6 is smaller. How about 2/3 or 8/12? Trick question. They are equivalent. If I were to take 2/3 and multiply it by 4/4, because that means I'm multiplying by one whole, and anything times one is itself. It's just with fractions, we're giving it a new name. So 2/3 times 4/4, which is 1, anything times 1 is itself, will give me 8/12. So they are equivalent. Now, there are a couple other questions down here I would love for you to write down. Take some time to answer them quickly and silently to yourself. Compare 3/6 and 7/12, 4/6 and 8/12, 9/12 and 5/6. If you're feeling really brave, you could answer these questions on the Whiteboard app, or even the Number Pieces app, any of the apps where you can write on it and share a code or a link or a picture with your teacher. Use Seesaw. You can do it on Seesaw. Maybe even Google Classroom. But answer those questions and send it to your teacher so that they see what you're doing in Number Corner and know that you're ready for this Number Corner checkup that's about to happen. Remember that for this month? All right, guys, that's going to end our day 12 of Number Corner. It was fun. I'll see you again tomorrow. Bye-bye.